Hi, Martin.
Hi.
Let me just quickly merge the rest here. Derek is also coming, and Pascal,
Yeah.
and
Camille?
is not coming because
Ah,
he had something that for this week. And this one, hi, Derek.
Hey,
hi. Hi, Greg. I don't think we've met before.
Yeah, can you, by the way, raise a pull request, Greg, that you are in this meeting?
Yes, I definitely will. Last week I joined and it got canceled, so I was waiting until
Oh,
just
for
to make sure, just to make sure.
yeah.
So yeah, I'll raise a pull request. And hey, I'm
Awesome.
Greg. I'm a staff engineer at Wayfair, working on the GraphQL platform. So
Awesome.
we use Apollo Federation. So I thought I'd start coming and checking out these
Great.
meetings.
It's good. Okay, we have one person short. Let me ping Pascal. Pascal. There's Steven.
Hi.
I need a pull request, Steven.
What's that? Any pull request?
Yeah, pull request for your attendance.
Not yet.
Just to keep the record.
Working on it.
Awesome. That's good. Like, sorry for the last two times, but conferences. Too many conferences. So I'm basically done this year. I don't know. Derek has one more go-to, I read.
oh, that was actually this week, so already done.
Oh, this week. Okay, you are also done? Or
Yeah, so it was on my talk was on Tuesday, so already done.
Yeah, awesome. Yeah, Martin, you should have come New York.
I
Was
know.
great.
Yeah.
Well,
Yeah. I've heard good things about it.
Yeah.
but he has already gotten the vaccine, so there's no need to go to the US now.
Nope.
No, the API
Awesome.
days are coming up, right? That's in Paris, which
Yes, but like I didn't like API Day so much because it's basically we presenting to ourselves, like a
yeah.
bit like that.
Yeah. I remember I think I was there 5 or 6 years ago. I think I was like the only GraphQL talk. It was
Yeah, so there was a GraphQL track last year. And
yeah, that's an improvement.
yeah, there was also a GraphQL user group in the evening, and that was the best user group I've ever been to because it was so funny. So we were there. So Chili Cream was there. Then there was 3 people from the guild. Then there were some people from Escape, from not from Wondergraph, but from Stellate, and only maintainers or providers, but no customers.
That's not necessarily a good sign, but
Yeah, no one
my-
knew about this user group except us, so we were just there
Yeah.
and sending our products to ourselves. So that was fantastic. Okay.
In a sarcastic way, yeah.
Yeah, obviously.
Right, I'm still on the housekeeping. Okay, looks good. Let me quick have a look. A couple of things we can talk today about. Let me just quickly pull up the notes. Awesome. Okay, let's get started. So let me remind everyone that by being here, we all agree to the GraphQL Spec Membership Agreement and to the GraphQL Foundation Code of Conduct. Let's do a quick round of introductions in the order of the attendees. And then we get started. So my name is Michael. I'm the host today.
Hey, I'm Derek from Apollo.
Martin, also from Apollo.
Pascal from Chile.
Steven of Netflix.
Greg from Wayfair.
Awesome. Okay, we have a couple of things I wanted to. So I'm at the moment refining the directives, putting like proper specification text into the directives. We going to go through that. Pascal has what was that? Yeah, Pascal wants to discuss the enum merging RFC, so we can make some progress on it and really get through the validation rules. And then we should go quickly over the list what is missing for finishing off validation. Like what rules are we missing that are maybe in Apollo Federation that we still need to put on our list of specification backlog for the validation chapter. Okay, so let's start with what do you want to start? Do you want to start, Pascal, or should I start?
Yeah, I can start. Don't
Okay.
worry. I mean, I've opened the RFC for the enum merging, and there was some great discussion around that last meeting. And Steven actually also posted their statistic about their graph, how many output, input, and shared union pipes they have, and it seems a bit like Derek had a very good point last time. Like we have to not only think about the case where we only have inputs or outputs or shared, we have to have a bit of a feeling how the enum feature is used, right? So, and it seems like there's a lot of enums which share the usage between output and input, probably through mutations when you change something, and then the output type when you receive it back. So I think for me to write the validation rules, we have to make some decision in what direction we want to go. This doesn't have to be final, we can still change it, but I don't want to write the validation rule and then have to rewrite it just because we discussed it again in the meeting, right? I think we all had some time to think about it. And for me personally, it feels a bit like we have to go into the direction that Apollo Federation initially took, that we have the shared enum use case, and just do the superset. But I wanted just to hear what your points are if you now have to decide in which direction you want to go. Any thoughts about that?
So I would say that for thinking from the user perspective, we probably should choose the one that is the most flexible approach, and that's why I'm also leaning towards how it's contextual in Federation, that that we have those inputs that are intersection, outputs are the union of all the things. I think that is the most flexible for the users. it does make some of the merging rules, right, a little bit like more complex than having explicit whether it's input or output. But I think that from like evolvability of the schema perspective, that's probably the best for the users. That's what I would lean towards.
Like
We like the implementation we went as a platform at Wayfair, we wrote our own custom rules to explicitly split the use cases. So force you down the path of explicit input, explicit output, because the merging rules, when you use it for both, become extremely challenging to manage. And so like my inclination would be to say it should either be explicit divided use cases so the merging is more straightforward, or to go with the most restrictive merging by intersection rather than by union to accommodate that complex use case. Basically treat it as if they're all inputs.
And how do you differentiate between input and output usage? Do you have like an additional directive?
We look at the use case. We look at the use case. So we look at where you're using it. And so once something becomes an input, you can't use it for a return enum.
Okay.
And if you're using it as a return enum, you can't use it as an input enum.
Yeah.
but that's
I
interesting.
think it's definitely interesting. But my inclination would be to sort of allow that more restricted use case to be defined on top of the sort of flexible approach. So when people decide to like restrict the usage, they can be explicit, maybe even mark an enum type as input or output. But for the sort of more flexible use case, we may still want to allow the sort of the current validation rules, and then you would sort of think about these rules as an additional sort of policy, basically.
Yeah.
So not to bike shed too much on this topic, we ran into an issue recently, and this is where like even our own rules didn't quite cover this use case, where a return type was being used in a requires directive, which made it implicitly a different kind of a request shape. It became more of an argument at that point. And so it blurred that line where the return type became an argument, and when a new enum value was added, the subgraph received that new enum value. It wasn't capable of handling that new enum value, and it broke that subgraph. And so we had the conversation about you got to defensively code to protect yourself from an enum that you may not understand because you're really a client once you introduce a required directive. But if it was treated, if enum return and input were treated as the same, where the same rules applied, where you can't have a new type until all subgraphs are capable of handling it, it would cover that use case. But throwing that out there as kind of a weird one-off kind of a thing we've seen.
Yeah, but it's an interesting case, because in Fusion, in the composite schema spec as it is now, you would have this as an input somewhere, as an argument or as an input type, because the for the requirement you have to specify the input that you want to receive. So just from analyzing the subgraphs, you would know that it's actually used, because these requirements are, I would say, more explicit than it was with Federation, where you have this basically any input where you just put in objects to be resolved. So we would have it validated, and we could have just the simple rules, the simpler rules, like for everything. We don't have to treat require specifically. But you have a very interesting point. If you require the output, then it also becomes an input. So that means that even if you from a schema governance perspective say that you only want to have this in an output, and this is the rule that we want to do, you will not be able to require it in a different subgraph. It's an interesting case.
Yeah, I found it also interesting because like we discussed that last time, where also Martin pointed out, if we mark enums explicitly for inputs or outputs, right? Like this now the second time also that a user of federation points out to have a simpler merging rule. Like, not that we have to give up the flexibility, but we have to think about the default behavior, maybe how we want to have it, or how we want to guide people in that direction.
Yeah, or at least what kind of restrictions we want to support for people if they choose to use them.
Exactly.
Because it's definitely, I think, from a schema evolvability perspective, there's definitely value in keeping inputs and outputs separate. Like, it does simplify schema evolution a lot.
Yes. Yeah, and at the moment you don't have tools, right? It's very unpredictable if you have such a flexible approach like we have in Apollo Federation today. And I don't say we have to give them up, but have guardrails around it, give people the tools to control that more.
Exactly. Yeah.
Yeah, Derek, go ahead. Sorry.
Yeah, I just want to mention what I wrote in the chat. It's kind of that is a very, very specific use case, the Greg, that you mentioned, but it is a very big gotcha that people may not know with the current approach of federation, because it is very implicit how you actually, with the current add requires, right? Those fields become inputs to something else. From the schema, you don't see that, right? But I think we are actually handling that and approaching that with the new, moving that to a field arguments with add require. So now those enums would actually have to appear in the schema as arguments, right? So that implicit, that would be now handled explicitly, in that implicity of the add requires on the, on the fields, that's no longer the problem there. But it is
it would be much easier.
Interesting case.
It'd be much easier to build tooling around that, certainly. I do think that, though, my kind of original point, which is that, like, there's a easy, it's very easy and very quick to blur the lines between what are inputs, what are outputs, and create irreconcilable merging, which is what I would love to try to avoid. Like, that's what ultimately drove us to make them have explicit roles, was because of those merging pitfalls.
Yeah,
And I think that's what I would caution.
But you have explicit roles, but not explicit annotations, right? So you sort of you analyze the schema and then you derive.
Yeah. We didn't make you have to decorate it as this is meant to be an input, this is meant to be an output.
But
we analyze, and then we lock you into the choice.
But do you see value in being explicit from the start there?
You could certainly do that. It would communicate what your intention was, and for somebody like us, where we want to force you down one path or the other, we could force you to choose instead of us locking you in, and then it makes it clear to the developer what they're choosing to do rather than us implicitly choosing for them. But I still would be concerned about the ones who want it to be both. How would, like, once we start, distributed contributions to those, how that would end up reconciling.
But what would be your preferred choice for these that could be both? You use that intersect?
I would treat it like an input. I would default to the input because it's the more restrictive merging strategy. Because you have to be capable of understanding what you're being given, rather than being able to return. You'll only ever return what you know about. So you can have an enum of 20 different values and you only know about 2 that you're capable of returning. But if you are only capable of accepting 2 and you're given one of the other 18, that's a problem. And so it would have to merge in a restrictive way. Or if you want to introduce it as an input, you would have to support them all. And so you would have to include all the node ones. And like that could be the path forward, right? Is you would have to bring in all the values that currently exist in order to start using it as an input. But then the evolution of it then has to switch to the model of input. I think the managing the merging would have to have some pretty nuanced consideration. And I think it could be done, but the rule set would have to get a little complex.
Yeah,
it isn't necessarily a bad thing.
If you use an input, if you use an enum as an input or an output, you have to use intersection. It's the only thing that works. we could also say that we default to intersection, and we say that we treat all enums as they would be shared. And we just have directives where you can say you want to flag them specifically as input and specifically as output, right?
Yeah. And then as an additional policy, you might actually like allow specifying sort of enforce usage of that input and output annotation. That would be sort of outside this spec, but you could enforce that as a matter of like company policy to force developers to think about these roles beforehand and not get into situations where you're sort of inadvertently buying into the shared use case.
Stephen has his hand up.
Oh yeah, I just Greg, I was curious when you at Wayfair started specifying input versus output, were you already using Fed2 merging rules? Okay.
Yeah, we were already using Fed2 merging rules, and we were running into problems where enums were created, their return types, their subsetting, and then people start using them as an input, and then people try to contribute change values, and the merging conflicts arose, and that's where we said we got to split these. But to I think it was Pascal's point, if we treated it as input merging logic, unless you denote that you are only going to use it as an output, then you could theoretically subset and only say the things that you're capable of returning, and that might be a good way to handle it. Would afford the flexibility, but make you have to declare I'm going to use this flexibility, because you only really have to have all the values when you are accepting it as inputs.
Yeah.
So.
Yeah, but I'm like doing the intersection of those potential enum values for the output types. That could lead very easily to runtime errors from the servers, that they have to know that they can only return those handful of them, right? Versus the ones that are doing, right? So as we said, like returning stuff, it's like, that's why there's we're doing union, right? Because any of those is valid, right? It may not ever return 18 of them, but it's still perfectly valid. With inputs, right, you have to know what you're going to get. So if you limit it out, it's coming from users, it's only those valid ones that you can accept. So that also works, right? But now if you're saying that output types are also intersection, that is very easy to return something that shouldn't be there, I think.
But not like the idea is to have intersect by default. So if you don't specify it, but if you specify that it's an output, in that instance, it could have different merging rules.
Yeah, I think the rule set would kind of come down to if you're only going to return it, you can choose a subset of any of the existing values. New values would have to be contributed where all input subgraphs must support it before you can make it not inaccessible anymore. So added across all input use cases. Doesn't have to be added across all output use cases. And that I think there could be a rule set that could end up evolving out of this that would give people flexibility to evolve it while avoiding the kind of merging pitfalls that we encountered.
I think I said something wrong before. So to that note, the intersection wouldn't work in a shared use case. You have to have the exact match in a shared use case, right? So we should.
So merging by intersection would mean that if you say ABC in one subgraph and CDE in another subgraph, only C would exist.
Yeah, but
that's accessible.
That wouldn't work for. You have to have an exact match, don't you?
In order for the other values to be present, they all would have to have A, B, C, D, E. Yes.
No, I mean, you would have to mark them as inaccessible.
And ensure that you don't return them at runtime.
Yeah. That's I think that's the composition exception that you should get, right? If you use an output type if you use an output enum as an input enum, and you do not have marked the others as inaccessible, you should get a composition error. Now the question is, should we go for this behavior by default and be really restrictive that you cannot reuse enums that do not have an exact match controlled by inaccessible, right? And only if you specify this is an output only enum or this is an input only enum, you're able to change it. So we would go for the most restrictive one, the one we treat all enums as they would be used as input and output and have to have an exact match. Only if you specify them as output or input, we would use the restrictive one, either the intersection or the union one.
Yeah. I think that is a consistent model. It makes sense to me. We'd have to think a little bit, I think, about forward compatibility with like the current behavior. Like we basically we may actually end up generating warnings, for instance, at first, and still supporting the more flexible behavior, and asking people to annotate their graphs.
That is anyway something we can talk about. Like we can specify it as an error, but allow for implementations to say, I'm generating here an error for a warning to have an upgrade pass, something like that.
Yeah.
We talked about like how we handle actually this. I have to look up the notes, what we said, if it's an appendix where we point that out. But I think this way, this would be a good way. It could also be that implementations choose to have the warnings as an error because they want to be more strict in other parts. But
Yeah.
I think, like as a default, being more restrictive forces people to think about what do
Yeah.
they want to do here, and leads to a better behavior down the line.
I think so. Yeah.
So to recap this, the default behavior would be, now we have two things to cover here. The default behavior in merging would be the intersection, right? The default behavior, we can talk about this. It doesn't matter if it's a warning or an error at the moment, but the default behavior for validation would be that if you have not annotated it, we will always tell you that you should annotate them as inaccessible if they're used in multiple subgraphs.
Yeah.
I think like if
So what-
I think if we're forcing it the equality, I think that should be if you don't have an accessible on those and they don't match, I think that should be an error, because otherwise it's very easy to return something that you shouldn't be doing that. The warning is not good enough in those cases.
Well, you know, the one problem is that it's enough that one subgraph marks it as inaccessible. So even if a developer is explicit in one subgraph and says, hey, I want to make this value inaccessible, another developer in another team might just add the field and is not aware of that it's inaccessible, because in their schema, it's there, you know, and it's not marked as inaccessible. So it's a problem that we had also discussed last time. It's either route you choose, there's always the downside of having inaccessible defined somewhere in a different place, and then it just works, but you still have the same issues that you could return the value because you're not aware of it. Steven?
Should the spec define what happens if a subgraph returns an unknown enum value, and just make that kind of an explicit behavior of the system that might happen sometimes?
I think so, but ideally we could detect that at compile time.
Detect
time.
that condition,
Yeah.
and that's either an error or a warning, or depending on how flexible you want to be, I guess.
Yeah,
So
but I agree.
when...
We also need to specify the runtime behavior. I agree with that. Yeah.
What are the options that we have there other than throwing error and setting the field
null, because we cannot. I mean, we cannot just set it to null, because that would be change of data. That would be not so good. So it probably would, I think, should be handled like an authorization issue. You know, you don't have access to it or something like this. So setting it to null and adding an error in the response and let null propagation do its thing seems like the most, like the only option that we have, right? The other one would just be cancel the whole request and say runtime error, sick kill, we're done. I think we need to have a separate discussion, I think, about error handling, and perhaps semantic nullability can help here. We can at least describe the behavior when that is supported. But yeah, I think we need more consistent error handling, and that's probably a separate topic. At runtime, yeah. But I agree. We should be very careful about what we do there, and we can't just like null.
I think it's relevant here because if we wanted to consider these options that make it possible for a DGS to be returning, you know, something that's not like post graph, even like the option 1 with inaccessible, you know, as Pascal mentioned, leaves a possibility that a subgraph accidentally does that. And so if the result of that case is not catastrophic, if it's like from the client perspective, I get all my data and I get an enum value that I don't understand, say, then from a client perspective, this is the same as if I'm an old client and the API is upgraded and added enum values that I don't know about. And that's already a case that has to be.
Well, but it would basically be an invalid response because the supergraph schema wouldn't include that enum value. And I don't think we should ever.
Oh no, we shouldn't.
No. What I think what Stephen meant here is like you have to handle it like on the client side. Because on the client side, you also already have to deal with enum values that could just appear, and that from the client perspective, from the client schema that is known to the client, does not exist. It is an error, but how do we deal with that?
Correct.
Yeah, I think this gets into that nuance between like why the choice was made between inputs being intersection and outputs being unions, because inputs you can control through the client API, you can control whether the client can send an enum value or not. But the response, you can't really necessarily control it as easily. So that this poses challenge to treating return types as intersection the same way that you would input values.
If we set federation aside, an enum value in your schema that is used as an output, is it ever safe to evolve that? Like, is that always a breaking change to add enum values?
It's actually
from a client perspective, you mean?
It's dangerous. It's a dangerous change, right?
Yeah.
But it's more the problem there is more about serialization, right? There is one case where you can still run into issues when you somehow input the values that you get to output them again. When you took the output values and put them as inputs again, but it's rare that this becomes a problem.
Yeah, and I think there are two different things here. Like one is evolving the supergraph schema and like how clients handle, for instance, additions to enums. But the other question is like changes to subgraph schemas. And even if those changes are not reflected in the supergraph schema, even if we take the intersection, it could still mean that we'll have to deal with those values at runtime. But I don't think we should ever return those values. Like we should never return an enum value that is not part of the supergraph schema. So we should
that would be a
catch
spec
those
violation.
errors.
Yeah,
Exactly.
No, it would be a graph code spec violation, right? And yeah, we shouldn't go there.
We could go the
Yeah,
exact opposite direction and say that enums are always merged as a union, all values, and subgraphs that receive them as inputs just need to defensively accommodate that.
We
Very
also
straightforward
talked about
rule that says you could receive a value that's invalid and that's the error, and you just need
Yeah,
to
but that's-
respond.
I
as if
think that's
an
also
error.
a spec violation, right?
Yeah.
I
yeah,
think
it would be blocked out in the either in the validation or in the coercion of the variables.
so you
Well, so
cannot.
to be clear, what I mean is if I have a subgraph that accepts colors red and blue, that's all they want to accept. The enum that exists in the supergraph actually has all the values, and so you may receive things that aren't red and blue, and that's okay. You just need to accommodate that and treat it as any other input error. We could go that direction,
But
and
that
just
would
be
that would go
variables.
against the subgraph schema. Like if the subgraph schema only includes red and blue, from a spec perspective, like the graphical request that gets sent to that subgraph should never include values that are not part of that schema.
So
Yeah, I mean, you can send whatever you want, but I mean, you would have to actually loosen the validation. And in most cases, it would probably also explode in the coercion even worse because you actually received something that you cannot handle.
Yeah.
So there, in the like normal graphical server, there's not really a way that you could write defensive code against it because it's the outer edge which will just explode. So as soon as you would request this, it would basically just say, I cannot do anything with it, right?
Eric?
Exactly.
yeah, so I was thinking like okay, how do clients actually handle this stuff, right? So for the outputs, since the schema can change and that's known that as far as I know, they all add this unhandled, unknown, whatever extra value in there. So like if we're going with the route of intersection on the inputs and outputs, maybe the behavior on the gateway should be that we automatically add for those outputs an unhandled case that is being all the values that are actually outside of the intersection, they are get coerced to unhandled, so then it's
Now you, in this case, you would push the data consistency problem to the client to handle.
yeah
And that's definitely not where you want to have it, because if you think about it, then
To fix this issue, you would have to deploy new clients. Whereas in the
Yeah.
backend, you can somehow, with communicating between the teams, do something right against it. But it would be one option, though. It kind of changes how the schema looks like, and now all the clients would have to handle the case where there is no enum value or there is a new enum value. So
Like basically like relay handles it, right? With the default case.
yeah,
But you encode it in the schema.
I think the problem that you get there is you just postpone the problem to someone else to handle, and it's really hard to understand from a consumer point of view now what actually happens. So is it not set? Is it there? Is it just a new value, or what did happen? And in the inputs, we would have even worse problem because we couldn't persist in the database, right? Because if there's an unhandled there, then cannot do stuff.
Even
So imagine if we did have let's say like a way to specify that one of the enum values is the default, like a default directive. And then if we have the merging rule for enums be strict by default, meaning they just have to be identical, unless you have a default specified, and then we can do like an intersection, say, and in the case that we see an unknown value, it switches to the default. Is that crazy?
No, not at all. I think that's
Um,
an interesting suggestion. Yeah.
I
puts
think again, I think again, there has two cases that we look at, because on the output we would have a default, but each subgraph would also have to have a default on the input. Because if you send a value that doesn't exist on this subgraph, then you would have to switch to the default, right? But
yeah, it also puts it back into the developer's hand. Like, we don't just magically do something. We give you the tools to handle this problem.
I think one thing which is challenging with the default again is that you do not know that this was defaulted, and because it's only one value, we cannot pass it to the developer to know that this was defaulted. But I think in the output it's probably not much of an issue, because you could just show the default in the UI, usually not so much of a deal. But in the input, I think this would be really difficult, because you do not know if, let's say A is the default, you do not don't know in the mutation if the user has set it explicitly to A, or if it's defaulted because he has sent something which I, as a subgraph, do not know.
Yeah, or maybe, well, like you said, at fallback instead, that encourages a best practice of this value never being explicitly sent and only used in the case of, a fallback.
Martijn?
Yeah, I mean, I'm still thinking this through, but I'm wondering if it would make sense to be even more restrictive. Like, basically, what I'm trying to think is whether we can sort of avoid more of these runtime situations if we're more restrictive at composition time. And I think the fact that we allow sort of adding values to an enum type in a subgraph, I mean, that in the end is what gets us into this situation. Because if the subgraph schema would not include additional enums, they wouldn't be returned. There might still be situations where there's a mismatch between like the subgraph schema that we've composed and the one that's actually running on a server, but those are really like uncommon situations. So I'm trying to think if there's an alternative way to evolve a schema. And I mean, the simplest case would be one where you do mark an enum as input or output only. In that case, we have consistent behavior, but we still want to support the shared use case as well. And I'm wondering if inaccessible is the right instrument there, or whether we want something else. And like fallback, I think is interesting. Look, our default, but maybe there's something else.
What would happen if we would say that you have to have a strict match of all enums in the shared use case?
Yeah.
And all the things that you do not define have to be internal and inaccessible.
Or just internal. I mean, doesn't internal imply inaccessible, basically?
Well,
we would be replacing inaccessible by internal, and I like that because it's subgraph specific. Like you cannot get into a situation where one subgraph marks something as inaccessible.
Yeah, but then you cannot evolve, because you would have to, if you remove internal from one subgraph, then, you mean, okay, you could only remove internal from a subgraph if all the other subgraphs also have marked it as internal.
No, internal, at the moment, we have internal just for the lookups, right?
Yeah. I mean, we can also call it something different to stop like at private. It could be that it's actually the same directive in the end, we don't know yet. But the problem that we have to solve here is, if now all the subgraphs add fields as internal, how do you remove the private at internal?
Yeah.
Then you need inaccessible to say that it's fine, that this should not be displayed, but yeah,
Yeah, that's why I thought it maybe internal, but that I came to the same conclusion that it still doesn't solve the evolvability of that problem, right? So again, going back to what was discussed, I think if we want to be as strict on it, saying that it has to be always an intersectional, I wouldn't call it necessarily the exact match. I would say if we follow the rule of intersection, right, then we have for inputs we're fine, right? So the clients are constrained what they can send by those data, right? So the problem in those was kind of what we do with the outputs, right? So the clients and the individual subgraphs, they can return new values on it, right? And that's why if we follow the intersection rule there as well, I think the one way forward is to have this extra default or fallback or the unknown unhandled, right? So in that situation, when the client gets it, is something that is not in the schema, so it implies a new value from the subgraph, right? Once other subgraphs added, it automatically gets added to the composition, starts arriving there as well, right? It's just that the problem I'm thinking about from the runtime perspective on a subgraph, so like how that would actually be handled, because other those directives from Federation, they're great, but for the most part, some graphs are unaware of them, how to do that, right? So if you add inaccessible, unless you add some extra logic to find that this is actually being run, there's nothing validating there that you cannot return it, right? Composition, yeah, it's gonna give you those warnings and all that stuff, but at runtime, you don't have anything to prevent you from returning that.
Yeah, because the values are acceptable according to the subgraph schema, but they're not acceptable according to the supergraph schema, which the subgraph doesn't have any visibility into. And so it ends up shifting the responsibility for the enforcement of the default, fallback to the default to the edge, which is whatever the router is that's managing the supergraph.
Yeah.
And so it's a detail that's lost on the subgraphs, and they're not going to understand. And honestly, from the client perspective, now you've got clients complaining that they're not getting that they're getting this default value back. Why are they getting this default value back? And the subgraph has no clue why, because to them it's not necessarily straightforward to debug.
You also
Which
get
makes
this
that challenging.
It comes to this weird behavior where you can read data from the gateway, and then if you write the same data, so let's imagine a struct. You read the whole struct and then you write the whole struct. The input type looks the same as the output type. It's not like how it's not often used, but it could be that you now return a struct with the default value because the gateway doesn't know it, and then you write the thing again, and then it would be modified even though the user has no intention modifying the state.
Yeah.
So if you read data and then write data, if we default it somewhere in between, then you change the state even though you never intended to.
But it's also a bit about how you implement that, right? If you like do it with a flow where you first bring in the enum value into all the subgraphs, then make it visible on the schema, and then just implement the function that returns it. So you make sure in your implementation of the subgraph that you first bring it into the schema, and only after it's in the schema out there everywhere, and then you put the implementation in. I mean, this could even be done with tooling around that. Then you would never run into the runtime errors, right? And then it would be okay to have the runtimes errors in the first place if it would happen.
So I just thought about something, right? So if we're going to a flexible approach with intersection and the unions, right? The problem there was with the shared type, right? And Greg was talking about also like if I'm sharing those, it causes issues, right? So what if the composition is actually smart enough to look at your subgraph schemas and automatically separates those in. So if it's used as shared type, it automatically creates input and output enums for you. So basically it does this translation, right? So from the supergraph perspective, you never have a shared enum, right? And it's basically you have a smarts in the composition to split it out for you. I know it adds extra logic to composition and all that stuff, but it would solve that problems, right? You don't have the runtime errors because it's always there. It would handle that. It's more logic to the router to coerce the values and all that stuff, but technically it resolves all that stuff.
I mean, it's not a wild idea because we already don't allow you to use object types as inputs. We already differentiate between input objects and output objects based on the input types and object types, right? And so the idea of having input enums versus output enums isn't too wild of an idea either, because then you're explicitly stating what is possible to be returned and what is possible to be accepted. And it eliminates all of the type safety and runtime errors. What it doesn't do, and this is the biggest complaint we've had, is it doesn't solve the I got a value back and I want to send a value. Now I have to do an enum to enum mapping somehow. People don't like that, but like of the issues that we've outlined today, I think that's like the less of the lesser evil. All things considered.
Yeah, I mean,
Because we haven't even talked about the removal of stuff yet. We've only been talking about like adding stuff. We haven't even started to talk about how do we take stuff away? Like how do we take enum values away when they shouldn't exist anymore? We haven't even touched on that topic yet.
Yeah.
Martin?
I think automatically splitting a type into an input and output version, that's too magical for my taste. Like it really modifies the supergraph schema. But enforcing annotation of an enum type with either input or output, that sort of gives you that same behavior, but in a controlled manner. So that's definitely like one way you could use this feature. I do think we also want to support the flexibility of a shared enum type. Like you could, this is sort of a it's a choice that you can make, and depending on sort of how you evolve your schemas, how much control you have over the subgraphs. But I wouldn't want to sort of force people to split their enum types in every situation. So
I mean,
some kind of opt-in feature that does make the most sense there to me.
if you think about it, this would break the composition completely, because you wouldn't be able to have to require an enum value anymore, because the output is different than the input. But what we do in the composite schema is we use the outputs as inputs. That's the whole selection map, the whole mapping syntax that we have there, right? We take the output.
But we do support that for we support that for like object types are output types as well, and we do support them as input there.
Yeah,
so the mapping syntax.
What I mean is that if you have if you take an enum and you split it into input and output, then the output and the input enum is different. So you cannot require it anymore because the types are different.
Yeah,
right?
Because you could have more because you merge differently. Yeah, but like my distaste for that in the first place is that it's unexpected. You have an enum, you define one enum, and suddenly it becomes two. And then you also have to deal with name collisions. What if now we have to introduce new names? So we would probably say this is the foo input one for the foo enum. But what if I have exactly that defined in another subgraph? So we get into a lot more other issues and have a lot less predictability.
Yeah, to maybe be clear, I would not magic split enums, but I do think it could, like I could argue for the idea of saying that they must be one or the other. Input or output, just like we have input object types or output object types versus the input object as an input. We made that decision not to allow you to take just an object type and use it as a argument input type. Same way, I could see that argument making sense for enums as well, because we are running into these merging collision issues. And I don't know how, when you can use it as both, how it could change over time it feels like as soon as it becomes used as both, it becomes locked in in its state forever. And the only way forward would be to deprecate that argument and return type or in that field and create new ones with the new enum that has the new values that you wanted to add. Which is a path forward, but it's a lot more churn, a lot higher lift to make that change.
Mm. Yeah, you said that you like the idea of, I mean, you see that the value of separating enum and output, input enums and output enums, and I agree. I think that but I don't think that, as you also think, I don't think it should affect composition, but it would be a really good organization policy, a schema governance policy, to say that in all the cases that is possible, we have dedicated enums, and only if we really have to use the shared ones, we will use the shared ones. So I think it's a good policy, and I think the documentation of Apollo Federation, of Fusion, and all the ones which will implement the composite schema should also have this like as an advice under the enum sections. Like, enums are hard in Federation, so keep that in mind, because you will like grow into it, and then you realize it when it's so late, right? I mean we now used way more than the 15 minutes. We only have I think
enums are complicated.
Yeah, I'm not sure if we have some like solution or common ground for it. I mean, we all agree that enums, I mean, we have a common ground. We all agree that enums are really complicated. We can also give this a thought and discuss it again. Yet,
yeah.
we would also like to I would also like to go into the validation. I would like to close down the validation phase at the moment and move on to the merging phase, right? So I think I will just write the validation rule, and then we can discuss it and we can roll with it until someone has a really good idea how we can solve it. And I think the output and input idea that you had, Martin, is really good, because you could basically enforce the schema governance policies easier that way. But that's also something that we can easily add on top. So if we can just agree on the default behavior that we want, for example, we have to strict match them and use inaccessible or something like this, then we can move forward. And if we have a better idea how we can do it in the future, we can still change it. So it's just some text in specification, right?
Yeah.
I think the contextual based one as the default is what Federation does at the moment, right?
Yeah.
And people struggle with that because it's not explicit enough. So I think what we could do in this specification is we try to be more specific about stuff anyway, like with the specific inputs in require. Let's just go with, we make it require. We make it strict equal, otherwise you have to use inaccessible. If you want to share, you can use enums whatever you want, input and output, if it's just in one subgraph. As soon as you start to share them across different subgraphs, they have to strict match, unless we use the default behavior of inaccessible, that you have to flag the fields inaccessible on a subgraph. This doesn't solve all the problems that we have, but it's somewhat more restrictive than what we have now in Federation. And it's also not completely unevolvable with, you're locked into the state forever.
And in
yes, and then go ahead.
In this case, we're using. I mean, I think it makes sense to start with the simple and safe, rule, like basically the strictly have to be the same, and then go from there. And that allows us to unblock and get everything else sorted out. But then even adding the caveat of inaccessible, I guess only if that's if inaccessible already is going to exist for other reasons, and we want to allow it here, then then that can make sense. But otherwise, say leave it like as simple as possible to allow ourselves room for the amazing option that we're going to think of a year from now.
Yeah, I really like this suggestion. I've never really liked the use of inaccessible for this use case because it's more like a temporary situation, right? So and it feels like it's something more specific. So maybe we can actually come up with something that sort of that expresses the intent better than inaccessible does, and maybe even avoids the situation where like one subgraph marks something as inaccessible, the other one doesn't, and it's still inaccessible. But the subgraph doesn't know that it is. But
Not new.
So Derek had last time also a very good point, and he said that what is the desired end state? Do we desire that the enums are the same across all subgraphs, or do we desire a state, or is there a case where the enums are on purpose not the same across all subgraphs?
yeah.
If
Well, for outputs, they can be different. For inputs, I think we want every subgraph to be able to handle all values.
Yes, although the problem is the outputs also get used as inputs. The side effect of a requirement means that you now have the output as an input. That's what.
Yeah, but we can even handle that separately. Like maybe that's where, for instance, a fallback does make sense. If you sort of make that part of the mapping syntax. Maybe that's a crazy idea, but maybe that's also something where you have to be specific about the intent.
Yeah. Okay.
Yeah.
Greg? Oh, I thought someone wanted to say something.
No. I was just thinking, like about the idea and the mapping syntax.
If it's
which
just,
could-
I'm not sorry about interrupting you. So.
Yeah, no, don't worry. I was just.
So, is this? Do you think that someone has a better idea than just to say we're going with the most restrictive one and we will use or maybe abuse the inaccessible for this use case for now, and then we just see like if we have any better ideas in the future, and if we do, then we can still change it. It's only a draft specification, but just so we get a step further, and we can basically say from a draft perspective, validation is closed, and then we'll move on to the next phase.
I think also having it written down will give us a better reflection over it. So once it's written down, it's always easier to iterate on that, because and also we buy us some design space when we are strict. In any case.
Awesome.
Sounds good. Yeah.
That's
Awesome.
It's not the best outcome, but it's a good outcome of this question because now we can move.
And I think we did make progress. Like I think we got more clarity on the problems we're actually trying to solve here.
Also, Greg, great input with the require. I have never thought about this, that the output actually gets an input if you require it. So that's
yes. Yeah, no problem. That's why I'm here.
Yeah.
Share all the horrible, painful things we've dealt with over the years.
Yeah. Yeah, I mean, and the fact that you do separate the input and the output cases, that's also really good to hear, like from an actual usage.
But the funny thing is that Stephen also came with the same issues here. It was one of the first pieces that let's make enum merging simpler.
The first interaction into the validation of enums was so the first iteration is they have to be strict equal. There's no evolution at all. And the first comment was from Steve was like, will this stay this way? Is it possible to change that? Okay, good.
Awesome.
Thanks for the input. Then I will go back to the drawing board and write some validation code for it. To the code.
Yeah. Yeah, we had more, but I think the next validation rules are not that contentious. The one that seems to be the most contentious one.
Yeah.
Awesome. See everybody next week.
All right. Sounds good.
Thanks, y'all.
Bye.
Thank you.